Hey, how's it going, guys? Welcome to LeetCode 1 2Sum. So in this problem, we're given an array of integers nums and an integer target. We're supposed to return the indices of two numbers such that they add up to the target. You may assume that each input would have exactly one solution and you may not use the same element twice. Looking at example 1 here, if the target is equal to 9, we know that 7 plus 2 equals to 9 and the output is 0 and 1 because those are the respective indices for 2 and 7. So before we get into the most optimal solution, we're going to take a look at the brute force way, just so that we have an idea of what this problem is doing. And it's always good to start with the brute force way and then get to the most optimal solution. I find that that's something that really helps me. So the output that we're going to do here is going to be actually target equal to 18. So we have a little bit different of an example. And let's just say it'd be 11 and 7, right? So that would be 1, 2. So how do we get here in terms of code? So the brute force solution will go through every single combination for the target. So let's have a for loop, an ith for loop here, followed by a jth for loop that goes from I plus 1 all the way to the end of the array. Because we know that 2 is not a solution and none of these, so 2 plus 7, 2 plus 11, 2 plus 15 equal 18, we're going to have to move the ith loop over. So the pointer would be moved over after we checked all of these combinations. And we would start the j loop and we would go till the end. But we know that right here, 11 plus 7 equals 18, so we would stop our loop here at nums I plus nums j, and we would return 1 because I is now at the first index and j is at the second index, and that would be our output. So what's the time complexity of doing the method like this? We know that for every ith element, so for every ith element, we're gonna go through the loop n times, so the rest of the inputs. So for every ith element, we're gonna go through the loop n times. So for every element, it would be O of n. And we know that there's n elements in the array, so our time complexity would be O of n squared. And our space complexity would be O of 1 because we're not storing anything. This is the brute force way where we're going to go through all the combinations until we force our way to the target, hence the name brute force. Now, let's look at a solution that's a little bit more intuitive. This would be 1, 2. Okay. So, let's think about what we need to look for when we're trying to find two values that end up at the target. So we'll have a loop that obviously goes through all the elements in the array because we have to see everything once. So first we'll start at 2. What added to 2 will give us 18, right? 18 minus 2 is 16. Have we seen 16 or 16 anywhere in this list? No, it's not. So 2 is probably not one of the solutions. Next we'll do 18 minus 7, which actually equals 11. We know that 11 is a solution and it's in the list. So what exactly do we need to store to get this information, and not just this information, but its index, which would be 2? This is where a hash map comes in. This hash map can keep track of everything we have seen so far. So let me just erase this. That way we can start the example over. So the hash map is a key value pair data structure. What this means is for every key, there's an associated value, which in this case, the key will be the number or the value in the array, and the value will be the index. And we'll keep track of everything we've seen so far. So we'll have a for loop that goes through all of the elements in this array. So we'll start at 2. Let's do 18 minus 2 equals 16. Have we seen 16 before? And where would we check this? We would check if the hash map contains 16. It doesn't, right? Because it's obviously we started the first index. So because it doesn't, we're going to move to the next element. But just before we do that, we're going to add 2 as a key, and we're going to store its index. Next, we're going to move over to 7. Well, we're going to do 18 minus 7, which equals 11. Have we seen 11 in our algorithm just yet? No, because we haven't reached 11 in our code. So we're just going to store 7 with the index 1, with the value 1 because the index is 1. Next, we're going to do 18 minus 11, which is equal to 7. Have we seen 7? Yeah, the hash map contains 7. So we can get the value 1 from the hash map because of the key value association. So we can get 1 as one of the results, and we know that because we're running a for loop through this array, that this pointer will hold the index value for 11, which would be 2, and that will be our output. And the reason we use a hash map to store things is because it's an O of 1 operation to add things into the hash map, and it's an O of 1 operation to look if something is contained in a hash map too. So given this, we know that the time complexity for this problem is O of n, and the space complexity for this problem is also O of n, because the space complexity is O of n because of the hash map, and at the worst case, it'll store all n elements. So let's go ahead and code this solution out. First, we'll start by making our hash map for all the elements that we have seen so far. So the integer and integer are referring to the key and the value, which would be the actual number value and the index value. New hash map. This is just how you initialize it in Java. And do for in I equals 0, I is less than nums dot length I plus plus. So first, what we're gonna do is find the difference, right? Like we just talked about. We're gonna see what number we need to get from the number we are currently at to the target. So we're gonna check if we've seen that value before, if we've seen that difference before. So we can check if the hash map contains the key difference. And if it does, that'll be our answer, right? We can just return new int. So since the return value is in the int array, and we can do seen dot get, we can get the index value from seen dot get because that's what the key value pair is for, and then the next index value would just be I because that's where we are in our loop. And if we haven't seen the key, if we haven't seen the key at all, we would just put the current value that we are on into the hash map with its index, respective index. And we're just going to return null at the end. It will never reach here because we're guaranteed a solution, so it'll eventually return it here, but I'm going to have return null just so I don't get any exception errors. And we'll just run the code. It seems to work fine. And if we submit it, it runs optimally. I wouldn't worry about this too much. It seems a little bit random, but this is the most optimal solution. Thank you guys for watching. Look forward to posting more videos, and have a good day.